Welcome to Sift tutorials. In our last tutorial, we created a few charts to monitor deviations in power curve efficiency. A manual check of these charts can be done quickly for one site, but this becomes very inefficient as we start analyzing more aspects of site performance and larger portfolios. In this tutorial, we will address this by setting up alerts to help us work efficiently and not miss any deviations from the normal that require our attention. On Sift Monitor, we can set up alerts on any visualization. For each analysis topic, we need to think about what we want to receive alerts for. This includes asking ourselves questions like what the expected noise level is and whether our observation is a significant enough outlier to require a response. Let's look at our power curve efficiency example. We see seasonal fluctuations plus some seemingly random noise resulting in values generally between plus and minus 7%. This means that when we alert on this metric, any alert threshold set within that range will regularly raise false positive alerts, depending on the time of year. Note that in practice, this would be a sign that the model could be improved. However, this series focuses on scaling analytics rather than developing them. To set up alerts on this visualization bundle, let's go to the template. We will first set up an alert to highlight sudden large deviations. In Sift Monitor, any alert threshold is applied to all samples in a visualization. Here, we are only interested in recent drops and not historical ones. To alert only on recent observations, we create a new tab in our bundle and reduce it to the last month only. As we are only showing one data point per turbine, we put turbine on the x-axis and change this to a bar chart. It is important to keep the intended monitoring schedule in mind when setting up alerts. If monitoring consists of weekly check-ins, alerting on the last month has a low chance of missing an alert activation. As this site shows normal deviations of about 7%, we set alerts on exceedances out with that range. As this normal variation can differ from site to site, let's create a variable to store the level of normal variation. Now, we are ready to set up our alert. Let's go back to our visualization and go to Configure Alerts. We can add an alert by clicking on the plus button. Let's name this alert Large Drop in Power Curve Efficiency. Then, we can enable it and set its role to be smaller than our variable, multiplied by minus 1.5 to alert on larger drops of apparent power curve efficiency. Different alert levels, ordered from low to high priority, are assigned across the full portfolio. In this portfolio, existing levels are information, warning, or critical. Let's set the level of this alert threshold to warning. Save the alert. We have now set up an automated warning alert to highlight sudden large deviations. However, this does not pick up on more subtle but sustained changes in efficiency. We can reduce the noise and seasonal fluctuation by averaging over consecutive samples. This comes at the cost of increased response time, but allows alerting with tighter bounds. Let's create a new visualization to also alert on the average deviation over the last 6 months. Select the option to squeeze n values, then set the aggregator to mean and the last 6 months. As the yearly seasonal fluctuation follows a sinusoidal pattern, averaging over a rolling 6-month period reduces its peaks. The new peak is expected to be about 2 over pi, or 63%, of the previous peaks of 7. We can set an alert by multiplying the normal variation by 0.6, then minus 1.5, which is minus 0.95. Let's make this alert a warning. Let's also create a critical alert when the 6-monthly average efficiency drops below 1.5 times the normal monthly variation. This logic can also be applied for full load monitoring. Looking at the visualization, we see much smaller oscillations between plus and minus 1.5%, and no clear seasonal component. We would then want to alert on one-off deviations larger than 1.5%, and sustained deviations with some tighter bounds. Next time the analysis is run, all raised alerts will be visible from the home page. In this tutorial, we created alerts to automatically highlight deviations from normal behavior while accounting for the possibility of different scales across sites. This concludes our tutorial series covering some of the important aspects of deploying analyses for the continuous monitoring of large renewable energy portfolios. Thanks for watching, and please reach out if you have any questions.